Today we're going to talk about section 1.1, points, lines, planes, and space. Today's lesson's a lot about notation and how things are put together. Notation is highly important in geometry, so we know what we're talking about when we name things. So let's go ahead and get started. The first part of our notes will always be definitions, the second part application. So here, we're talking about a point. A point is a location. Same thing as saying on a coordinate grid, point XY, it's a location on the coordinate grid. Exactly the same thing. It has no size, no dimension. Dimension is your length, width, and height. And it's named by a capital letter. With that, you have maybe a line, AB, and we only want to talk about one point on that line. So we would just write A in a block capital letter to identify point A. Now, fancy girls, this is not a capital letter. That is not identifying point A. That's not identifying point A. We could do the same there again for B as well. And you don't need to write it, let me move this over just a little bit here. Sometimes people want to write it like this. The textbook will write it like this, but you don't need to write it like that. We're not really going to do non-examples, so we'll just fill in the example part farther. You don't need to write it like this. This is saying point A, and this is saying point A. So you don't need to write them like these. Just plain old A block letter by itself is perfect. A line. A line is straight. It's one-dimensional. It has no endpoints. It's infinite in both directions. Goes on forever. That's why you put arrows on the end of it. With that as well, and I'm going to make this really big for a second because I'm going to write a really tiny word. It has no measurable length. And it doesn't fit in the blank. But by definition in your textbook, it's going to say it has no length. But it has no measurable length until you look at a segment of it. So it does go on forever. So it has no measurable length because it does have a length. It goes on indefinitely. But it has no measurable length until we look at a segment of it. It has no thickness. Although, Word lets us to have different thicknesses. It has no thicknesses. It's named by 2 points. Any 2 points create a line. And it's also named by a lowercase script. So I'm going to draw this line up here that we had before, AB. And now I'm just going to throw letter C in the middle of it. Doesn't matter. So when I'm talking about this line here, I can write it as line AB, line AC, or line CB. It's all the same thing. Now with this as well, sometimes you're going to see this little letter hanging out on the outside. That's that lowercase script. Script is that italicized when you're writing in Word. It's also cursive writing. So I could just here put line L as well. I don't need to write line L. I don't need to put the little symbols above it. Just the lowercase script L means that line L because it's identified off to the outside. Okay, the next thing we're going to talk about is a plane. A plane is one of those ambiguous things we talk about. You'll see it in this unit. You really won't see it again, but that's where all your lines, your rays, your angles, and everything sit on. It is flat. It is two-dimensional. That's because it can expand by length and width. It has no edges, no thickness, but here it says that it will extend infinitely the surface in both directions. Now, this is the important part about our plane. Sorry, I'm making that larger. Is that it's named by by an uppercase script. I got out of order here, sorry. Or 3 non-collinear points. Okay, so before we start talking about these three non-collinear points, let's talk about what a collinear point is. Let's jump down to in our definition right here and talk about collinear points. Collinear is just like it sounds. Co means like coexist, you both exist. Co means you're on the same thing. Linear means a line, so it's points on the same line. So if I'm looking here, again, that's a bad looking line, but A, B, and C are collinear because they are on the same line. So now up here, when we talk about three non-collinear, that means if I have this, and they always draw, for some reason, they always draw a parallelogram as a plane. I don't know why. You have your uppercase script in the corner, which is a fancy P. Then I'm going to have 3 points on my grid. I can't draw a line between them because they're not in a straight line. That's non-collinear. So we would call this plane A, B, C. Notice how there's nothing written in front of it. There's no marking, there's no nothing. That creates a plane. When you start looking at angles or triangles, that's why you have to have the symbol. So just 3 uppercase scripts name my plane. Now, where does the plane get wackadoo? All right, let's just say I'm going to have a plane. I'm going to draw it off to the side over here. Let me move my paper over. So I have this plane right here, and I have this line crash through this plane. And I have these 3 points over here. This line is not just randomly sitting in space. This ABC plane is imaginary. That's what people hate about geometry. It's imaginary and can create its own plane because they're non-collinear. So don't think that this line AB that's crashing through this plane, they're intersecting it, do not think that by any way, shape, or form that it is just randomly in space. It is created by this plane ABC that you don't see and is imaginary. So speaking of space, we will only talk about space this one moment in time. Space is just the set of all points, and it's 3D. It's just where everything sits. That's all we're going to talk about it. It's not that important. But it's important to know that's where everybody sits. Okay, coplanar points. Just as collinear points sit on the same plane, collinear points sit on the same line, coplanar points sit on the same plane. So when we were looking at this plane we had here, I think we called it P, fancy P. So let's just say I have these points A, B, C, D. They're all coplanar points because they all just sit in the same plane. That's all it means. I sit in the same plane. Intersection is just as it sounds. It's when you have 2 figures, it's all the points that belong to both of them. All your points are in common. Now it looks different for different things intersecting. For one, if 2 lines intersect, like this, where's their intersection going to be? Well, obviously it's just going to be here in the center. So lines intersect at a point. So if I asked you here, this line intersects this other line, you would say it's at point A or point B, whatever it is. If I have 2 planes, now I'm not a very good drawer, so I'm going to try to draw 2 planes here. But 2 planes, when they go ahead and intersect, this is not going to work, but it's okay. That looks too weird. Okay, when you have 2 planes that intersect, because we use this ambiguous parallelogram, it's going to look like our planes intersect at a line segment. But you have to remember that these planes go on and on and on forever, and where planes intersect, they intersect in a line, not a line segment, because these lines, go on forever and ever and ever, And so even though these two crazy planes that I couldn't draw correctly are crossing each other or intersecting each other, there's an imaginary line formed. But because the planes are flat and go on forever, it's going to be a line opposed to a line segment. The last thing that we're going to talk about, because it comes up in a lot of our definitions, but it's not on this page, is something called an opposite ray. Now, you will see this come up in a lot of our definitions, but it's not, you'll see it come up in a lot of our definitions, and it really is just in a definition. But an opposite ray just basically is, if I have this line, oops, where's my line? Hold on. I have this line, ABC. An opposite ray says that on here, to create this line, because an opposite ray really is just a line, that's all it is a line, that I create a ray from BA going this way, and I create another ray BC going this way. So it's opposite rays that create a line. So here, it would be ray BA and ray BC are opposite rays. They have the same endpoint and they go opposite directions, but ultimately they're going to create that line. The last thing I'm going to sneak in by a definition, and then we're going to do some practice, is whenever I have planes intersect, planes always intersect in a line, no matter what. Except, because there's always a rule of exception. With my planes, let's just say I've got this cube. Well, it's not going to be a cube. It's going to be a parallel rectangular prism. With this rectangular prism, each side of it is a plane, and they're called a face, because you'll see that come up later. Faces only, that's what a face is. It's the outside of the box of tissues. But what occurs here is if I have three planes intersecting and I'm in this kind of figure, then the only way they're going to intersect is at a point. It is the only time that planes intersect at a point. So in these 3D figures, because of the way my planes are designed, it's the only way, because if I'm looking at it, I'm going to try to draw this so you can see this, but if I have this plane here, I have this plane here, and I have this plane here, the only place they're all going to intersect is right here at that point. It's the only place they're going to have in common for all three. And it only happens in 3D figures. It's one of those weird exceptions. Otherwise, all planes intersect at a line, even ones that look like little windmills. Because if I have like one that's in a windmill, and I'll draw that up here, let's just say I have a plane that looks like this, and then you have another one coming through like this, they're still going to intersect at a line. Okay? All right, so let's move forward now and do some practice problems. All right, so the first thing here says, write in words which each of these following symbols mean. Well, we know when we have a letter by itself that's capital like that, that's block letter, it's going to mean a plane. Sorry, it's not going to mean a plane, it's going to mean a point. It would be a plane, and I'm going to write that off to the side, if it was a cursive. Sorry, it's not cooperating with me. If it was a cursive letter like this, then it would be a plane, but a block letter is a point. Okay, so for B, here we're going to have line segment or segment MN. That's all you have. You have segment MN. There's no lines on it. If there was a little line symbol like this above it, then it would be line MN. And again, if it was a little scripty by itself, that's going to be line L. Just so I know our notation. And something else, that's okay, array. Some people got confused with array before. When you have array like AB, the A is the end point of the ray. You can't write that backwards at all. It's just ray AB. You can't write it backwards. All right, so here, looking at our little figure off here to the right, it says, give 2 other names for line BD. Okay, so first, with line BD, I could use my script EL, because it's here at the end, or I could write it as line DB. Another name for plane T. All right, so here I have the T written out to the side. Another name for plane T would be our 3 non-collinear points. There are many of them up here. I could have CAW, remember they're all capital. I don't need to write the word plane. I could have up here BAD. Any 3 non-collinear points are going to create the name for this plane because they're laying on it. Name 3 points that are collinear. That means they're on the same line. So, CAN. I could also have MWH. Either one of those are acceptable answers. Name 4 points that are collinear. That's just 4 points that sit on that plane. The only ones that don't sit on the plane are M and H because they are on that line that intersected that plane. Everybody else sits on that plane. So I could put B, D, C, A, W, N. All of those are coplanar points, but it only wanted 4 of them. Okay, name the intersection of line TY and line PY. First of all, name the intersection of 2 lines is always going to be a what? Exactly, a point. So here I have TY, which is over here. Looks like a segment, but it's really a line. PY comes across this way, so it's just point Y. Name the intersection of plane THD and plane EHD. Right away the symbol should have come up as, hey, I'm going to need a line because 2 planes intersect at a line. And it's THD, which is the front piece over here. And it's EHD, which is up here. So it's line HD. Just going to erase my little marking so that you can see the next one. All right, I'm going to name the intersection of plane EYP and plane TUP. Right away, ding, 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 it's going to be a line. EYP is this back piece over here on the back. TUP is this piece down over here, so it's going to be line, YP. Okay, number 9, it says, are points Y, P, and A collinear? Any 2 points make a line, so let's see. But here we have Y, P, and A. Y is way over here. So we have Y over here, P over here, and A over here. Are they in a straight line? No, they are not. They're not collinear. Are they coplanar? Well, they're all on that back plane, so yes, they are coplanar. They sit in the same plane. Are Y and D collinear? Well, Y and D sit right here and right here. All right, this is the weird part with that. Any 2 points make a line. If they create a line, then yes, they are collinear. They're on the same line. Any 2 points create a line. Are they coplanar? Now this one has an ambiguous kind of thing. Right away you're going to say no, there's only 2 points. But technically you could fight the answer yes because of the fact that they have to sit somewhere. Somewhere would be in a plane. If you tried to Google it, it would tell you that any lines, if you have a collinear line, it has to be coplanar automatically because it has to sit somewhere. So either answer you could fight for that one. All right, so just to end, the last few things, a point has no dimension. That means no length, no width, no height. A line has one dimension. Here we're going to say it has length, but remember that's non-measurable length. It's just because it's infinite in the long direction. It has no width and it has no height. Any 2 points determine a line. So if I saw 2 random points sitting and hanging out, bam, I can make a line. A plane has 2 dimensions because remember that surface goes on in the length and the width. So it has a length, it has a width, but it has no thickness because it's not going to expand thicker. It's like a piece of paper just getting longer and longer and longer. 3 non-collinear points determine my plane, and then there's an infinite number of points sitting on my plane. So here, this is just a little thing to see if you can pay attention. Symbol N means intersection. So, what does this mean? I have the intersection of line M is the little m, plane N is the big N, and point R is the block R. That ends our first section. Have a great day.